Okay, so hello and welcome to this video tutorial for the Engineering Mechanics Statics textbook by R.C. Hibbeler. So we have this problem here from chapter 2, which states determine the magnitude of the resultant force and its direction theta measured counterclockwise on the positive axis. So let's just kind of crack on with this problem as we ordinarily would. Let's draw our free body diagram. So we've got this 15 kilonewton force here, and we've got this other 15 kilonewton force acting here, and we've got this 20 kilonewton force acting here. Let's just add some labels to these. So we can say that's acting at 20, that's acting at, sorry, that's not acting at 20 at all. That's acting at 15, that's acting at 15, that's acting at 20. And let's just add some geometry to this. So we've got this kind of 3, 4, 5 triangle idea here. And I believe that's everything we need. Okay, so let's start off by resolving horizontally. Why not? So horizontally, this 20 kilonewton force doesn't have a horizontal component. These 15 kilonewton forces do. Each one will be 4/5 of 15, right? So we can say FR comma X, R meaning resultant force, X meaning its horizontal component, is equal to, in this case, let's say 2 times 4/5 of 15, which when I bung in my calculator, I find is equal to 24. Let's move on then. R comma Y. So let's look at the vertical components that we've got here. So we've got this 20 Newton force acting up. We can also consider the vertical components of these 15 kilonewton forces, but note that this 15 kilonewton force kind of acting in the bottom right direction, and the 15 kilonewton force acting in the upper right direction, they have the same magnitude vertical component. So the amount that the F1 force is going down is equal to the amount that the F3 force is going up. So they cancel each other out. We can ignore that. We can just kind of stick with what we've got here. We can say the Y component of our resultant force here is 20. Okay, so we have the vertical and horizontal components of our resultant force. Let's diagrammatize that. So it's acting 20 across, and it's acting it's acting 24 across, and it's acting 20 up. And we're being asked here, let's just label this up. So it's going 24 across, it's going 20 up. It's got a magnitude, let's call it FR. What we're being asked to find is this magnitude and this angle, essentially, measured counterclockwise on the positive axis. So that will be the angle there. Okay, how could we find, let's pick one, let's say theta. How could we find theta? Well, we've been given the adjacent, we've been given the opposite, might as well use tan then. So we can say that the tan of theta is equal to opposite over adjacent, which in this case is 20 over 24. We can take the inverse tan of both sides. So the inverse tan of 20 over 24 is equal to theta is equal to, and when we bung that in our calculator, we find it's 39.8 degrees. 39.8 degrees there. Okay. Let's move on then and solve for FR. So you might spot that you can just use Pythag here. So we can say FR is equal to the square root of 20 squared plus 24 squared, which when I bung in my calculator, I find takes a value of 31.2. And there we have it. We have our angle with the positive x-axis taken counterclockwise, and we have our magnitude. I should really add the unit there, shouldn't I? Kilonewtons. Cool. So if you have any questions or comments about that problem, please feel free to leave them in the comment section down below. Otherwise, thank you very much for watching.